Hello, this is the assignment for Tableau Desktop 5, where we'll be doing the map geographic data, creating simple and filled maps, creating a density map, creating calculated fields for deeper analysis, and working with string and type conversion functions. Alright, so I've read through the creating simple and filled maps, and now we're doing the try it section. I've already downloaded the file below to use with this activity. And now I'm going to follow these steps to complete this activity. Open the starter file in Tableau. I have already done that right here. Alright, so now we're going to create a map called European Airports that uses size and color to indicate the number of 2021 passengers at each airport location. Include the names of each airport. Alright, click on the hint. Double click the worksheet, type sheet 1, type European Airports. European Airports. Click enter. Alright. From the data pane, drag IATA to the view. Alright, and that's loaded. From the data pane, drag 2021 passengers to size on the marks card. From the data pane, drag 2021 passengers to color on the marks card. From the data pane, drag airport name to label on the marks card. Alright, and so this is what it looks like, and let's look at the expected result. And yep, it's the same. So on to part 3, or step 3. To help focus on the airport data, use the options for map layers to set the background style to normal, display coastlines, remove country region names, and remove state province borders from the map. Alright. Click the map menu and select map layers. Map menu, map layers. Maybe it means background layers. Set the background style to normal. Select the coastline map layer. Clear country region names and state province borders to remove those layers from the map. Country, region, state, province. Alright, and that's the expected result, and that is what we got. Alright, step 4, format the circles to have a black border, no halo, filler on labels, and 75% opacity. Click color on the marks card. Display the border menu and select the black color. Click outside the menu to close the border menu. So, display border menu, select black color. And that changes the borders of those circles. Display the halo menu and select none. Alright, so that's the difference. There's with halo, with none. Move the opacity slider to 75%. I'm just going to type in 75. Alright, and that's the expected result, and that is what we have. Step number 5. Revise any unknown geographic locations, Tableau Desktop only, which is what we have, and add a filter to the view with a slider for 2021 passengers. Alright, click the special values indicator. So I can close this out. special values indicator. 1 second. Alright, so the special values indicator is right here, and then click Edit Locations. Click the unrecognized cell to match a known location to the airport data, a search box. So click unrecognized cell. To match a known location to the airport data. A search box appears. Type MAD in the search box. Which brings up the correct IATA abbreviation and select MAD. Click OK. Add a filter. This step varies depending on product. Tableau Desktop. Okay, so that's what we have in the data pane. Right-click the 2021 passengers field and select Show Filter. So 2021 passengers field, select Show Filter. The filter slider allows you to set the map to show specific segments of the data, such as the top few busiest airports. Alright, that is the expected result, and so it allows us to see all this, the filters for 2021 passengers. Alrighty. Great work. You've created a simple map that shows us the busiest European airports in 2021. To complete this activity, use your work to answer the following question. Using the map you've just created, which is the second busiest airport? Second busiest airport. Alright. And how do we find second busiest airport? So I'm pretty sure, let me zoom in here, because these are the busy ones. So London is the busiest, I believe. So I'm pretty sure it's Paris is the second, and it is. Alright. And this is just to view the solution, which I've got. Module summary, and this module you'll learn how to visualize. I don't need to go over this. Basically, alright, I've completed the creating symbol and filled maps, and I'll see you in the next try it section. Alright, I've read through creating a density map section under the map geographic data part. And I've downloaded the file below to use this activity, hailstorm damage, and now I'm going to follow the steps. Open the starter file in Tableau. I have already done that. Off the video. Step 2, create a density map called Minneapolis Hailstorm Damage Reports by Neighborhood that places a mark on the map for each street address with a damage report. Alright, the hint. Switch to a blank worksheet. I am on a blank worksheet. Let's see if they want us to add another sheet. Nope. Okay. Double click sheet 1, type Minneapolis hailstorm damage reports by neighborhood. I am just going to copy and paste this, so I don't have to type that all. Copy, enter. Alright. In the data pane, double click the latitude and longitude fields to bring them to the view. From the data pane, drag street address to detail on the marks card. If you see a warning, click add all members. So street address to detail. And then it said if I see a warning, click add all members. On the marks card, change the mark type to density. Alright, and that's the expected result, and that's what we have. Step 3, add neighborhood information to the map as a tooltip. From the data pane, drag neighborhood to tooltip on the marks card. Neighborhood to cool tip. Expected result, yep. Alright, step 4. Modify the map appearance so you can clearly see the area with the most reported hailstorm damage. For this exercise, set the color to density, multicolor, light, and intensity to 50%. Alright, so for the hint, click color on the marks card, then from color menu, select density, multicolor, light. Density, multicolor, light. I'm pretty sure it's that one. Set the intensity to 50%. Alright, that's the expected result, and that is what we have. Step 5, the last step I'm pretty sure. Yep, explore the density map to identify which neighborhood has the most reported storm damage. And hover the mouse pointer over the areas of the density map with the colors indicating a high density. Note the neighborhood names to identify which neighborhood has the most reported storm damage. Note the neighborhood names to identify. So this is the highest density one. There's Downtown West, Hennepin, AVS, just in this section basically. Alright, great work you've created. Here's the expected result. You can just see that. Great work you've created a density map that shows the location of each damage report so you could spot trends in the mapped data. Knowledge check. Using the map you've just created, which neighborhood had the highest density of hail damage reports? It would be Downtown West. Let's see if we're right, and we are all right. And this is just the solution file. Alright, we've learned how to visualize geocoded information by building a density map and how to customize its appearance to reveal location trends according to the number of overlapping data points. See you in the next try it section. Alright, I have just completed the creating calculated fields for deeper analysis section, and there seems to be no try it section for this, but there were a few walkthroughs just to show. This is the last knowledge check, just showing you that I answered that. Don't need to go through that question, but in this module, I gained familiarity with use cases for calculated fields, the formatting for calculated fields, and methods for building basic calculations. See you in the next try it section. Alright, I have read through working with string and type conversion functions, and now we are at the try it section, and this will be the last hands-on activity for this week's video for the Tableau Desktop 5 assignment. I have already downloaded the file below to use with this activity, Student Data Starter, and I'm about to follow steps below to complete this activity. Step 1, open the starter file in Tableau. That is always the first step, and as per usual, I already have it up. Step 2, create a calculated field name, student name, and ID that contains uppercase student last names. In the calculation editor, name the calculated field and then use a string function to convert students' last names to uppercase. Add the calculation to the view without closing the calculation editor. Alright. On the hint, at the top of the data pane, click the drop-down arrow and select Create Calculator Field. At the top of the data pane, what am I hitting drop-down on? Top of the data pane, drop-down, Create Calculated Fields. Alright, in the name field in the editor, type student name and ID. Student name and ID. In the calculation area of the editor, type and use autocomplete to add the Let me go on to the next thing. Oh, okay. In the calculation area in the editor, type and use autocomplete to add the upper string function applied to the student last name field using the following syntax. Upper student last name. Let's see. Let me see something real quick. All right. Create calculated fields. Student name and ID. In the calculation area, maybe if I hit OK here. No, okay. In the calculation area, editor type and use autocomplete to add the upper string function. Okay, upper using the following syntax. Upper. Okay. What is going on? Edit. We'll just go select it. Upper. There we go. And now type student last name. So do this, student last name. Perfect. Now we're getting somewhere. Click apply to add the calculation to the data pane without closing the calculation editor. Apply. Without closing the editor, drag student name and ID from the data pane to rows. To rows. Alright, and that's the expected result is what we have right now. Step 3. Add students' first initials to the calculation. Combine the uppercase student last names with a string function that converts students' first names to first initials. Be sure to include a comma and space after the last name and a period and space after the first initial. Apply the changes to the view without closing the calculation editor. Look at the hint. In the calculation area of the editor, add the fixed string, comma, after the upper string function using the following syntax. Alright, so we'll add a plus sign, and then this, comma, this. After the upper string function, okay. Next, type and use autocomplete to add the left string function applied to the student first name field using the following syntax. Alright. I'm just gonna copy and paste that in there. Yep, looks good. Ooh. You know, I'm gonna not copy and paste that in there. Looks a little left. Okay, I think student first name, comma, 1. I'm missing the plus in between this. That is what is wrong. Okay, now the calculation is valid. Add the fixed string after the left string function using the following syntax. Okay. And then add period. Click Apply to preview the changes in the view without closing the calculation editor. Alright, and that changed right there. This is the expected result, and that's what we got. Step 4, add students' IDs to the calculation. Combine the uppercase student last name's first initial with a type conversion function that converts student IDs to strings. Be sure to include ID and a space before the ID. Apply the changes to the view without closing the calculation editor, and then save the changes and close the editor. Alright, the hint. In the calculation area of the editor, add the fixed string ID to the end of the calculation using the following syntax. So just plus ID plus ID. Is there a space after that? There is. Alright. Next, type and use autocomplete to add the string type str type conversion function applied to the ID field using the following syntax. Plus str_id plus st, and then ID Click Apply to preview the changes in the view. Alright. Click OK to save the changes and close the calculation editor. OK. That's the expected result, and that is what we got. Great work. You've created a calculation field using string functions, a type conversion function, and concatenation. Alright, and now we've got all this. Download, and this is just to show the solution, which is just this. Now let's check. You want to combine the fields, product type, and product ID while also making product type uppercase, adding a dash and space between product type and product ID, converting product ID from an integer to string. Which of the following calculations achieves your desired result? Let me think about this real quick. Alright, the only one that does all three of these, I'm pretty sure, is this, because make the product type uppercase, do that, and then you add a dash and a space between product type and product ID. You do that right there. The dash and the space. See, dash and a space. And then also converting product ID from an integer to a string. You would use this function. Let's see if that's right. And it is correct. Alright. In this module, you've learned how to use basic string function to clean and change the appearance of string data. You also concatenated string data fields and used a type conversion function to convert an integer field to a string. Now you'll be able to use calculations to work with your string data. Alright, and that is all for, well, I guess 3 try it sections and the one just read through module, and I will show that I've finished all those in a moment. Alright, right here, I've completed creating symbol and field maps, creating a density map, creating calculated fields for deeper analysis, working with strings and type conversion functions, and that is all we had to do for the Week 6 Tableau Desktop 5 assignment.